Thank you for the introduction. And first of all, I would like to thank ARC for giving me an opportunity to put forward the Siemens Perspective on the future of manufacturing and its link to Industry 4.0. I'll start my presentation with a small film. This film is from one of the Industrial Association or Federation of Germany, ZWEI, that is ZWEI, which is a group of all the electronic players or industry players in Germany. And this film will also set the basis of what the future of manufacturing holds for us. And once we go through the film, then I'll continue with my presentation. So can we have the film, please?
It will be completely networked and control production autonomously, and in a way that is more efficient and uses fewer resources than ever before. The possibilities are so vast and groundbreaking that many experts refer to it as a fourth industrial revolution, Industry 4.0. The first steps towards Industry 4.0 have already become reality. It all starts when mass production components become a unique item, with their purpose predefined at the outset. Because even before manufacturing, the component exists in virtual reality, including all the information required for its production. But all the other necessary components also have to be mapped into the virtual world. They also get names and addresses and thus an identity, so that they know where and when they are needed in a production line or process. Equipped in this way, they are able to negotiate their way through the digital factory for kilometers before reaching their destination. Arriving at the processing station, the workpiece is identified and the machine calls up in real time all information needed for processing. After each station, the work gets checked automatically, either optically or by using other measurements. Deviations from target specifications can thereby be discovered on the spot and faults can be eliminated quickly. If a machine needs replenishment or maintenance, it issues an appropriate request before shortages or breakdowns are experienced. The amount of resources used is immediately recorded in the system and stocks get updated. During processing, all relevant data for the product is stored in its own digital product memory. This means that every stage of production can be traced precisely. In the factory of the future, machines and workpieces will even communicate directly with each other and make autonomous decisions about the next production step, comprising a system that is decentralized, efficient, and flexible. For this, so-called cyber-physical systems are the key enabling technology. But for all this technology, humans are still crucial. Even in a highly automated production environment, creativity, experience, and the ability to assess and evaluate situations remain irreplaceable. Though technology can provide valuable support, operator safe controls innovative products. Some important questions need to be resolved before factories become truly smart, including topics such as standardization and IT security. Yet the opportunities provided by Industry 4.0 are enormous. Productivity can be increased by up to 30%, and both the quality and diversity of products will significantly rise. At the same time, the period between development and production will shorten. Thus, Industry 4.0 will make a decisive contribution towards maintaining and improving Germany's competitiveness as an industrial location center.
Can I go back to the presentation? So you can see this is actually the Siemens factory in Germany, which is already a living example of some of the key steps which have been taken already for moving towards Industry 4.0. Industry 4.0 is actually an evolution of the whole technology area, and I will go through my slides and we will show you what exactly is today present, what is the reality as of now, and what future developments will happen in this area for finally achieving improvement in productivity. How did this Industry 4.0 terminology come in? It is just actually just one of the visions of the future of manufacturing coming primarily from Germany. But you have similar schemes and initiatives also from other countries. Like US has the manufacturing renaissance as one of the initiatives which is moving towards achieving the same end, that is the future of manufacturing and achieving more productivity. What is important to note is that the government and the world over governments, the trade associations, the corporations have realized that, and also realize the significance of creating their own value add. And this is the key factor. The value add is very important, and that has to be optimized further at each and every step of the production process, and that is what all are moving towards. In Germany, the government commissioned a high-tech strategy group to ensure future competitiveness, and this has been dubbed as Industry 4.0, and that is how the terminology came up. Over the period of time, it has also become a global terminology, and I'm sure over the next years, because if you go to the next slide, you'll see that the evolution is a long-run process. You will hear more and more about Industry 4.0, and what it means will be clear in the further slides. Commercial enterprises face major challenges the world over. I mean, we all know that they need to increase their efficiency, reduce time to market, and improve their flexibility. When you talk about efficiency, basically energy and resource efficiency are today the key parameters which they would want to work on. Reduce time to market by introducing new products faster, and that means what you need is a shorter innovation cycle, and which also is characterized by large data volume or handling of large data volumes across the whole chain. And also we need flexibility. Individualized mass production is one of the characteristics toward which the manufacturing industry has to move towards, and also simultaneously take care of the volatility in the market. So all these challenges which the industry faces, we feel that Industry 4.0 should be able to overcome it over a period of time. And let's see how. Following the introduction of electronics and IT, which is to increase the degree of automation in the 60s, further enhancements were primarily done in productivity by integrating the product development process and now the production life cycle management. The key, what we see, what Siemens feel is the seamless integration of the product life cycle and the production life cycle, and this is what has to be a total seamless integration, and this is where the movement or the development is happening towards. And we have seen the benefits of this in the subsequent, some examples we will show in the automotive industry of how the improvement in the productivity has happened by having this basic thing done. But it is not easy to do it. There's a lot of work which has to go beyond the seamless integration of this data, and I'll tell you exactly how we went about it in the subsequent slides. So, but important feature of Industry 4.0 is that it offers unique introduction to the world of cyber physical systems. Now this is a new terminology which, at least when I got involved in this, I heard it for the first time. The cyber physical system forms the basis of Industry 4.0. It is characterized, as you can see there, basically you will have everything connected with the aid of sensors and RFID chips. That means the products which are to be manufactured, the transport systems which are involved in manufacturing, and the tools which are involved will be communicating with each other in an organized manner, finally to achieve better productivity or overall production improvement. And I can tell you, the German government appointed initiatives has a lot of working groups already in Germany, more than 25-30, which are represented by various industries, where a lot of development work is already going on in this aspect. And we also saw some prototypes in the meantime, and it is still under development, but it will soon be a reality in the coming years. You can see that the timeline which we have shown here is that finally the cyber physical based system will be operational or mature enough only from 2025 onwards. But before that, a lot of building blocks have to be put in place, which we have already started as part of Siemens initiative, and which is already giving a lot of dividends to many industries. So let us get into what we see as the Siemens way of moving towards Industry 4.0. Broadly, you can define a typical manufacturing or a production process into product design, the planning, the engineering, the execution, and the services. The need of the hour is, and to get substantial improvement in productivity, is to integrate all these stages of the value chain through a seamless data connection. And for this, we need very strong industrial softwares and a lot of investments required to be done on the development of a common platform across these software networks. And this has been the basis or the essence of what Siemens have moved toward and done very effectively. That means for each product, alongside its physical depiction, we need a digital depiction also available, need to be there for the complete life cycle. That means you need to have a digital model, and this is also one of the prerequisites when you have to move towards the cyber-physical system or the world of cyber-physical system in the future. So the founding blocks or the basic blocks have already been put in place by having this integrated or seamless data connectivity. The digital model of the whole value chain is in the development phase and already in progress at many stages in many industries. And then this sees, once you have then the cyber-physical part also developed and coming in the later years, this will give you a complete picture of how the productivity overall improves. So what we have come out with is what we call the digital enterprise platform. Here is basically a cohesive data connection across every stage of the value-adding process, and basically it means integration of the real and the virtual world. And this is what Siemens has been propagating as part of their digital enterprise platform. With this, Siemens has already started work from 2007 onwards on this platform, and we are already placing the product development process and the production process on a common database platform. And in the subsequent slide, you will see that how we have been able to do that. The advantages which we have seen here is that if you look at the PDM, the product design management, the product lifecycle management, these were always there as various, you can call silos or products available as in their own respective areas. And we have integrated that along with the production process. And with that, we already see those who have been the early adopters or those who have already started using it in their industry. Basically, the automotive industry in Germany, we have references to show you there, where already you can see the benefits coming out of this. And with this seamless data integration, we see a good improvement in the productivity by having this integration of the production and the product life cycles in totality. It also means that we are not talking about just a data connectivity in any form, like typically by a data export or an import functionality. We are talking about real seamless integration, a common database running across the complete plant. The advantage of that is that if you have to make a change in the product or if you want to add a new product into your portfolio, you can do it in the digital world very fast, and simultaneously, because the digital model is available, this is easily possible to be reflected in the physical world also too fast. So this gives you the advantage of having a flexible line with shorter time to market, and all these benefits can be seen accordingly. So what we have done exactly is shown here. From 2007, when we started moving towards the digital enterprise platform, Siemens has invested around $4 billion already from 2007 in acquiring a lot of these software companies which are listed here, and another $4 billion to integrate all of them to form a common database. So we are convinced that with this digital depiction of the complete value chain, we will be able to achieve whatever conceivable advances we have to do or achieve in productivity. And this has been the basis of it. You will see a lot of companies, the names of a lot of packages or software packages, many of them have been acquired over a period of time. But the aim or the basis or the difference has been that we have also integrated all of them on a common database platform. To give an example, the total integrated automation, which is what the world of PLCs and HMIs are familiar with, and the PLM cycle on the product design and production planning, we already have a lot of development done so that whatever is developed in the PLM cycle, you can easily integrate it into the PLC programs. So we have gone to that extent. It is still under development, but in the factory, in the movie which we showed there, it is already in operation. So those who are in Germany sometime later during the year, we can always arrange also for a visit to our Ambek factory, and you can see to what level the digital factory concept has been working. Just to give you a further illustration of the portfolio which we have for discrete manufacturing. So this is available, and a complete database. This is basically to depict that a complete common database is available across the complete value chain. All the 5 sections of the manufacturing process has the team center, the NX, the Technomatics, and the Sematic IT all integrated on a common platform. And this will then give you the benefits of getting productivity improvement. Now let us take an example of a reference where we have done this successfully. As usual, most of the references, I always tell our German colleagues that most of the new things which we do is always coming in from Germany, and that happens to be automotive industry, because Siemens and automotive industry have a lot of things in common. And so this complete integrated approach is also done in the automotive industry as one of the key references, and BMW is one of them. The plant in China has already implemented to a large extent. I'm not saying in totality right up to what Industry 4.0 is expecting, but to the extent of digital enterprise platform, that is a seamless integration of the PLM and the production life cycle has been implemented here, and you see the benefits of this. A common production line of BMW now can be used to produce many more models of cars on the same production line. Coming to that, even the factory which we showed in the film, we have around more than 1,000 product variations in the Ambek factory of Siemens on the same production line. And that is all possible is ensuring the overall time is improving of the manufacturing, and having flexibility of the variations in the product cycles or the variations in the product. The digital model forms the basis, and integration to the physical world is then going to ensure that you achieve your productivity there. And of course, this has also helped in low downtimes in high quality area. But there is a lot still to be done to achieve Industry 4.0. What I have spoken about as the Siemens, what Siemens has been doing is only the building block or the starting or the prerequisite to move towards Industry 4.0. And but what still needs to be done, and this is being done by the working groups which I was talking about, is to work on the machine and product exchange information and instructions in real time, autonomous control and optimization. These are the areas which will take a long time to come. It is not going to be easy. But the basic foundation of the digital enterprise platform itself is showing good amount of improvements and benefit to the customers who have started adopting it. So this can, in nutshell, tell you what further needs to be done. The rule framework and the architecture for dynamic topology still have to be developed. You have to extend hugely the communication between the machine-to-machine communication has to be further increased. Integrated process simulation needs to be done. But I can assure you, all these have very strong working groups working behind that in Germany and in other parts of the world. And I'm sure that by 2020 or 2025, we should have a lot more to hear on this aspect. So this is all from my side. Siemens is, because of the digital enterprise platform already being in place and seeing the benefits, I feel that the basic building block is already in place. And as we move towards Industry 4.0, we would be well poised to address the needs of the industry in the future. Thank you.